Hello everyone, welcome to my chemistry channel B.L.DASH, short and sweet in chemistry. Now I am going to explain, that is introduction part 8 in numerical application in chemical kinetics. Now I am going to explain collision theory and Arrhenius equation. Already I have explained a little bit in part 7. Theory of collision. Collisions between molecules for a reaction. That means collision takes place between molecules when the reaction starts. But you are not sure that all the 100% of collisions are very important to give product. Only a fraction of the total collision and that gives product, and that is called effective collision. Let 100% collisions are there, but all are not effective, all are not giving product, only a fraction, that is called effective collision. Then for effective collision, what happens? The molecules have sufficient energy and proper orientation. When the molecules come to close each other, there should be some orientation in space so that they can collide easily and in a proper way, in proper orientation, and sufficient energy also. The rates of reaction is proportional to, then rate of reaction is proportional to what? The number of collisions per unit volume per second between reacting molecules, what is called collision frequency. The rate of reaction depends on the number of collisions and what is that having per unit volume per second, that between reacting molecules, that is called collision frequency. That means rate of reaction depends on collision frequency. For effective collision, for effective collision, the colliding molecules have some sufficient energy or more than that minimum energy what is required, and that is called threshold energy. Again see, for effective collision, the collision which gives product, the colliding molecules must have more than or equal to threshold energy, which is called minimum energy. With increase in temperature, we know with increase in temperature, kinetic energy of molecule increases. Then effective collision also increases. Again see, when temperature increases, kinetic energy of increases, that is in case of molecule also, and also the effective collision. What is effective collision? The fraction of collision which give product. Proper orientation takes place. Increase in the rate of reaction with the rise in temperature. When rate of reaction increases with rise of temperature, because your kinetic energy also increases, this is not due to due to increase of effective collision. Effective collision means number of collisions which gives product. The molecules which give product have that is called effective collision. So increase the rate of reaction, that with temperature, it is due to only increase of effective collision. Effective collision what? That means it produces product. A fraction of molecules only can give product. So K equal to A e to the power minus EA by RT is called Arrhenius equation. Already also explained in class part 7. A is the Arrhenius factor, and that is it is also called frequency factor or pre-exponential factor. And EA is activation energy. A and EA are the important for the characteristics of the reaction. From EA, one can say what are the characteristics of the particular specific reaction. So it is called Arrhenius parameter, because the scientist Arrhenius who invented this equation, so it is Arrhenius parameter. E to the power minus EA by RT, that is the fraction of molecule have greater than EA. This is the fraction of molecule having value more than EA. Let the bimolecular reaction A plus B give product, that is a bimolecular reaction, sure. Then rate equal to Z AB e to the power minus EA by RT. That means here rate equal to, this is a new equation following the Arrhenius equation, and it is the rate. Then here ZAB mean this is collision frequency of A and B, because it is a bimolecular reaction. A and B are the reactants, so the rate equal to ZAB e to the power minus EA by RT. Clear now? Then you will see rate is directly proportional to rate constant also. So you can say here the rate equal to ZAB e to the power minus EA by RT, and rate that also rate means K also equal to ZAB e to the power minus EA by RT. So that means you can observe that sufficient, and besides the requirement of the sufficient energy, besides only they are not only important sufficient energy, molecules have proper orientation. Before also I told, that means in a space for collision to give the effective collision. That means the collision which gives proper product. That means they have proper orientation. You know, when reacting molecules come to each other, collide each other, there should be proper orientation so that the bond between the molecules that should break. So proper orientation should be required. For effective collision, factor P also called orientation factor or steric factor. It is also I explained in video 7, previous video 7. Then so K equal to what? K is the rate constant, so K equal to P ZAB EA minus EA by RT. Then A in Arrhenius equation, that is equal to PZB. So instead of PZAB, that because AB that is a bimolecular reaction, so here you should put AB. So what happened in A in Arrhenius equation is A equal to PZB. So as we know, K equal to, in Arrhenius equation, K equal to A to the power minus EA by R by RT. When you compare this equation, so you can say A equal to PZAB. So here you can say what is the meaning of activation energy in reversible complex. When there is a reversible reaction takes place, then what happened? Activation energy complex is formed, the energy representing activated complex is called transition state. That means, see, when the reactants molecules are there, then if there is be collision takes place, then some fraction of molecule only give product. So reactants absorb, take activation energy. So I have put here plus sign. This is I am putting here plus sign. So activation energy, it gives activated complex and also called transition state. So here then activated complex or transition state, when energy released, then what happened here? It gives product. Again see, activation energy when taking by the simply reactants, and here effective collision takes place by observing activation energy, that is called produce activated complex or transition state. The reaction takes place both in forward and backward reaction. Then what is reversible reaction? If the reaction takes place forward and backward reaction, then it is called reversible reaction. You can put the sign, the arrow mark right side, that is forward, arrow mark back side, that is backward reaction. The activation energy for forward and backward are not the same. Remember, forward reaction, what are the requirement is not same as by the backward reaction, and immediately activation energy also are not same. For exothermic reaction, activation energy forward, see, exothermic mean when heat is produced, delta H negative. For exothermic reaction, EA forward is less than EA backward. You can write here when delta H equal to negative. So it is the minimum representation of exothermic reaction. For endothermic reaction, EA, activation energy of forward reaction, more than EAB. So that is why it gives delta H equal to positive sign. So here what happened, exothermic reaction delta is negative, that is why here backward reaction is more, and here in endothermic reaction forward reaction is more. Then activated complex in both cases are same. Activated energy in both cases are different. Remember, activated complex though is form the same, but activation energy different for forward and backward reaction. Progress of chemical energy on the basis of activation energy. How the activated complex is formed? We are not saying about exothermic or endothermic. We only see how the progress of reaction takes place by the help of activation energy, how the activated complex or transition state is produced. So here ET means in this diagram you see this ET that is called threshold energy, and this is activated complex, that is, this is also called transition state A dot dot B dot dot B. That means here this is ER mean that the ER mean energy of reactants, EP mean energy of product. You can observe a backward reaction is more than forward reaction. So here this is the diagram, and here the minus, you are putting minus, and here the value of backward reaction is more, so delta H is the small value. And now the this is not any exothermic or endothermic, this is the value given. And now when you will express exothermic reaction, then the time delta is negative. So the product species form a result of forward reaction combined to form as reactant as backward. You know very well what is forward reaction. When reactants gives forward direction as a product, and when the reactants in backward direction form as reactants from the product to reactant, that is called backward reaction. Progress of reaction in exothermic. Now it is exothermic. See, delta H is negative, and here EA forward reaction is less, EA backward reaction is more. So EA forward and EA backward. So since EA backward is more, that is why delta H sign is negative. I hope this diagram, this graph, plotting graph is clear. The y-axis that is energy, and x-axis that is progress of reaction, and this is the intermediate step and that is called transition state or activated complex, and here delta H is negative. Again see properly where delta H is negative. Why? Because backward reaction is more, activation energy of backward reaction is more than activation energy of forward reaction. That is why the value is negative. Negative means energy release, energy produced. So it is called progress of the reaction in exothermic. Then come to endothermic reaction where delta H is positive, energy, this is in y-axis, and progress of reaction that is in x-axis. And here you can find the EA forward reaction is more than EA for or activation energy for backward reaction. So activation energy of backward reaction is more than activation energy for backward reaction, that is called activation energy of forward reaction is more than activation energy for backward reaction. This is in one sentence, so that is why it is confusing. Activation energy forward reaction is more than backward reaction. So what happened? EAF more than EAB. B mean backward reaction, F mean forward reaction. So delta H equal to EAF minus EAB, that is positive sign. So progress of reaction with catalyst and without catalyst. With catalyst means here you will get with catalyst the energy required less, so lowering energy. So, and without catalyst, and this energy is more, and so here without catalyst time is taking, and also but there is no change in product. In theory you can understand very well the what is with a catalyst and without catalyst. This is the diagram you can observe clearly, and if you look like this then it is very confusing, but find out each line, each word, and here this is reactant side, this is product side, and without catalyst you see the activated complex is at high place where it is with catalyst down, so lowering the activation energy. EA dash C mean catalyst, B mean backward reaction. EA, see here, this is EA dash A, C mean with catalyst. EA dash C mean catalyst, it is forward reaction. Forward reaction having lower activation energy produce the product. Similarly, EA U and F, EA U and F mean here uncatalyzed, and here also see uncatalyzed EA, this one is uncatalyzed, then this is the product. So here you will observe that lowering activation energy takes place with help of catalyst, and it is very helpful in the industry level because with catalyst lower activation energy required, and also time is saved. So again see EA on mean this line you read properly, EA UN mean uncatalyzed, EA dash C mean catalyzed. Similarly uncatalyzed, catalyzed you can find, this is clear, and then we will see. So you can draw the diagram at home and make practice at home, otherwise but it's very important for the board examination point of view as a graph. Progress of reaction, a hypothetical reaction A plus B, that is AB. Without catalyst what happened? A plus B reactant, and it gives a transition complex, activated complex without catalyst where activation energy is high, and it gives AB product. With catalyst what happened? A plus B reactant, and here with catalyst it gives a transition activated complex, transition state where C is required, where this is the C where your catalyst is used, and there is a bridging between A, B, C where A, B are reactant and C is the catalyst. After breaking it gives AB as a product and plus C as catalyst as before. What is the constitution? There is no change in constitution of the catalyst, only simply left as catalyst, and the product is formed with low activation energy, and time also saved. So I hope it is clear.